On this page, we start looking at more complicated equations that are still linear equations. And I think of this as a three-step process. Now, the first step of this process is really what's new here. We're going to start sort of what I call tidying up at the beginning of this before we start doing things to both sides of the equation. So I consider this step as tidy up each side and possibly clear fractions. So I'll explain more about the clearing fractions in a second. So when I say tidy up each side, what I mean is that before we do anything like add 5 to both sides or whatever we might want to do, I want you to look at both sides and see, are there any like terms that can be simplified? Is there any parentheses that can be dealt with? And so when I look at this guy right here for part A, each of those are as simple as they can get. However, if I look down on the next example, you can see that these are not as simple as they can get. There is some simplification that can be done with distributive property and combining like terms on that negative 5 times x plus 2 minus x. So for the first two problems, we're just going to kind of deal with the fact that there's variables on both sides. So we're jumping right in at step 2 and step 3 for these first two examples. But then you'll see that in the upcoming examples, we will be using the tidying up idea to get all of our equations basically to look like the equations that you see right here with this particular problem. So when you have a problem like this, where there's variables on both sides, you can get to the correct answer more than one way. However, I recommend that you begin by highlighting the variable parts on each side. Those are called your variable terms. And then your first goal should be to use addition or subtraction to get these so that the term containing the variable is on one side of the equal sign. Now specifically, we're going to want it isolated on one side, but first we just want to get it on one side. We just want to get the x's both on the same side of the equation. So I use addition or subtraction. In this case, I'm going to use adding x to both sides. And then this becomes 6x because I added 1x to 5x. The plus 3 sticks around, nothing happened to it. Minus x plus x becomes 0 plus 5, which is 5. So now we need to get the variable term all the way by itself, because right now it is on the same side of the equal sign, but it's not all by itself. It's got the plus 3 with it. So my next step is to get rid of that 3 by subtracting it from both sides. And now my variable term is all by itself. So notice that all of this was step 2 so far. I used addition and or subtraction to both sides of the equation to rearrange it so that the term containing the variable is isolated all by itself on one side of the equal sign. And once that is done, then I can use multiplication or division to change the coefficient of the variable to 1. So in this case, I will use division by 6 to get x. And that means that x is 2/6. Now, when you have a fractional result, it's helpful to reduce the fraction. And so I can divide both numerator and denominator by 2 to get 1/3. So my solution to this equation is x equals 1/3. And you can check your answers on these as well. We'll go through some examples on this page of checking as well. So let's take a look now at part B. For part B, we are going to try to get the variable term, again, on one side of the equation with nothing with it. And so I think the easiest way to proceed here is to use addition of 4,400x on both sides. And then on the left-hand side, those cancel out to 0. So it becomes 3,200 plus 0 is equal to, and on the right-hand side, those are like terms, so I can add their coefficients, 5,400x. Now in this case, I actually am already having my variable term isolated on one side of the equal sign. And because it's equal, regardless of which one goes on the left and which one goes on the right, I can even now kind of flip this around and they'll still be equal. And to finish this off, we will use division by 5,400. Which leads me to 3,200 divided by 5,400. Now from here, I could divide both, for example, by 100, just to get the numbers to be a little smaller. You can also, by the way, use your calculator to help you with this. That's fine. And then from here, even if you just start small, like if you notice that they're both even, you can chop them down into smaller numbers. And from here, now it's going to be easier to see that, well, 16's basically got prime factor is 2, and 27's prime factor is 3, so we're not going to be able to reduce this. So therefore, x is equal to 16/27 is going to be my final answer here. Now, as we go on to the next problems, you'll see that they all turn into problems that look kind of like these two problems right here. And so as we're going through these, just remember that you want to always pause and do a lot of practice on something before you go to the next level. So you may want to go look for some sort of simple looking equations with variables on both sides in your Connect homework, and again, practice them over and over again until you feel like you've got them down. Now for this example, we need to tidy up each side individually before we work with both sides of the equation. So I'm going to rewrite this as 2x minus 3. I can't do anything to tidy up that side. But on this side, I'm going to use the distributive property to multiply each of the terms inside the parentheses by -5. And then I just have to make sure I keep that minus x around. I can continue to tidy up the right-hand side by combining the like terms that are both x terms. So I have -5x, and then minus x is like -1x. -5 minus 1 is -6. So we get -6x plus -10. And now this problem looks a lot like part A directly above it. So we go back to the same goal. We say let's find our variable parts. And once we've identified our variable parts, let's try to get them together on the same side of the equation. So I'm going to use addition or subtraction to do that. In this case, adding 6x, I think, is the nicest way to proceed. So we end up with 2x plus 6x is 8x. We keep the minus 3. Negative 6x plus 6x became 0 plus 7, or plus -10. So that's still a -10. And now on both sides of this, we're going to try to take the step of addition or subtraction to continue on our path of getting that variable part all by itself. So remember, if we keep that goal, we keep trying to use addition or subtraction to get the variable part by itself, then that helps a lot in deciding what to do next. So on the left-hand side, we end up with 8x. On the right-hand side, -10 plus 3 is -7. And finally, we can use multiplication or division to get the variable to have coefficient 1. So I divide both sides by 8, and I get the final answer, x equals -7/8. On part B, it's really almost exactly the same process. So you'll just see another example, and I'll do a little less talking us through it. I'm I'm just going to demonstrate the process. So again, we use the distributive property. Be careful here because -8 times -2 becomes +16. And we continue to just tidy up both individual sides before I do anything to like add, subtract, multiply, or divide both sides of the equation by the same thing. Again, we want to get the variable parts identified, and we're going to use addition or subtraction to get them on the same side of the equation. So I would use adding 8x to both sides. This is a 1x, so we get 9x minus 5 is equal to 18. But I still don't have my variable part all the way by itself. I have that -5 there, or -5. And so next I'm going to get rid of that by adding 5 to both sides. So now I have finished using addition or subtraction to get my variable part by itself. And so now I'm going to use multiplication or division, in this case division, to get my coefficient of my variable to be 1. And this leads me to x is 23/9. My last examples are clearing fractions right at the start. And so when we're clearing fractions right at the start, this is a little bit like the tidying up process. But you do end up doing things to both sides of the equation for this. And so I'm not going to walk us all the way through how to do this, although I will give you the final answer that goes with each of these so that if you want to continue through to the end and see if you get to the right answer, you can do so. So I would recognize what is the least common denominator across any fractions. And in this problem, there's really only one denominator. And so that's going to be my least common denominator. And then I'm going to multiply every single term by 5. So on this side, it's going to look like -5 times this entire fraction. On this side, it's going to look like 5 times 6 plus 5 times x. And that means that these cancel. And so the entire problem becomes -3x plus 2 is equal to 30 plus 5x. And then you continue, and your final answer will end up being -7/2. So use that as an exercise. Try to get to that solution yourself. They are actually listed as steps in the filled guided notes, so you can go through and follow the steps there. Now on part B, the least common denominator is 4, so I'm going to multiply everything by 4. And by everything, I mean every term. And terms are separated from each other by addition or subtraction. So each of the terms gets multiplied by 4, which gets rid of the fraction. And as we simplify this, it turns it into something that is, again, more like what we solved above. So from here, I want you again to use this as an exercise. This should lead you to the answer x equals -24/5. Or it's also okay to have that as a decimal because it doesn't involve any rounding. So that's the same on this one. It would be fine to write it as -3.5. Just be careful about writing it as a decimal if you have to do some rounding, because then your answer is less exact. Now on the next page, we're going to work with solving proportions. Solving proportions can actually be managed with all of the tools we've learned so far, but they're specifically solving equations where we have a fraction equals another fraction. So if I have something that looks kind of like this, where I have fraction equals a fraction, we're going to find that we can use something called cross multiplying to solve it. So before you go on to the next page, you may want to pause and go do a bunch of practice on what we have so far. Or you may choose to go on to the next page Go over the solving proportions part, and then I would recommend a lot of practice on these before you go on to the solving literal equations.